Problems from your worksheet on products and quotients that was due today. Some problems we didn't get to go over in class, but you probably need to do or need me to show you. The first thing I would do on this one, I think it was number 2 on your worksheet. Let me see. Yeah. All right. So on apparently, when I pulled up calculus memes, I got this. So apparently, infant calculus is a thing. But anyway. So what I would do here is not the quotient rule. When I have a single denominator, I would just divide it up into 2 fractions like this. And so I would make that 2x, subtract your exponents, and you get 2/3 plus 5x to the negative 1/3. So then g prime of x, notice that I haven't marked g prime of x yet because all of my work so far has been on the original. Now I'm going to do the power rule, so I have 4/3 x to the negative 1/3 minus 5/3 x to the negative 4/3, and which is your derivative, and you could work with it to find the slope of the tangent line. But if it's multiple choice, you would go through negative exponents, common denominator, and then factor. Go through those 3 steps. So I'm going to get my negative exponent taken care of, 5/3 x to the 4/3. And then I'm going to get a common denominator. This is negative exponent. Common denominator, so I want a common denominator, which is 3x to the 4/3. And so what do I need to multiply this by to get a common denominator? Because they both have this in it. I need x to the 4/3, so I need to multiply this by x to the 3/3, which is just x. So I have 4x minus 5/3x to the 4/3 is my answer to number 2. If you did the quotient rule, please don't do it both ways, but if you had happened to do the quotient rule here, you would have gone low, mark what you're doing, g prime of x, you would have gone low, d high, minus high, d low, so it's 1/3 x to the negative 2/3 over, then you square that, and I'm going to call that x to the 2/3. All right, take care of your negative exponents, which is right here. And what I would do is just put it right underneath here with this 3. So this is 3x to the 2/3. So this goes right underneath what it's attached to. And this is x to the 2/3. Then I'm going to get, sorry, I was thinking about my problem. Now I'm going to get rid of the common denominator on the top by multiplying by 3x to the 2/3 on the top and the bottom. Distribute, that'll give me 3 times 2 is 6x, and if you add your exponents, you get just x. And then when I multiply this, it cancels. Be careful with your minus sign. It gives me minus 2x minus 5/3x to the 4/3, which you see is the same answer, 4x minus 5/3x to the 4/3. But think about this is far better if you can break it up into 2 fractions. All right, now next I'm going to do number 3, quotient rule. First of all, I would see if it would factor and reduce, but x squared plus 1 doesn't factor, but check that, because you are allowed to factor and reduce it if it's feasible. So this is, let me get that problem. Okay, so then I would say y prime is low, d high, minus high, d low, over low, low. All right, then I would see if it has anything in it that factors. This, in fact, factors, and you could take out a 3, which I'm thinking would leave me x squared minus 1, which is x plus 1, x minus 1. But it doesn't have anything to do with this over here because this is a cube and probably won't factor. So I don't have negative exponents as I go down my list of things to do. Or I don't need a common denominator. I tried to factor and I couldn't. When you've exhausted all of that, then you really just do multiply it all together. I'm not going to do that right now, but your final answer I think was x to the fourth plus, I can't read my writing, 6x squared minus 4x minus 3 over x squared plus 1 squared. Let's do that really quick. I need to give you the right answer. So that's 3x to the fourth minus 3x squared plus 3x squared minus 3. And this is minus 2x to the fourth plus 6x plus 4x. Alright, so I have 3x to the fourth minus 2x to the fourth is x to the fourth. And, oh, I missed this here. That would be 6x squared. So that's my plus 6x squared. And then I have, let's see if that's my x squared. Then I have plus 4x, I guess. And then minus 3. So let me double check that sign, because I keep seeing minus 4x in my work. Oh yeah, it should be minus 4x. I missed that sign right here, because that's behind a minus sign. So it's right the first time, so it's minus 4x. All right, now next problem we're going to do is problem number 4. So this is number 4. And while I'm pulling up number 4, I'll give you the answer to number 1, which I think most of you got. Let me move this down. All right, going back to number 1, the answer to number 1 was x cosine x plus sine x. All right, write the equation of a tangent line. So I'm going to need the slope of the tangent line. So I'm going to take the first derivative. It doesn't reduce, so I'm going to say low d high minus high d low over low low. By the way, be sure you practice the chain rule because this sheet doesn't have maybe any chain rule on it. So make sure you go back and practice your chain rule. This gives you x minus 1 minus x minus 1. And so my x's cancel, and I get negative 2 over x minus 1 squared. Now let's go on and read the problems. Equation of the tangent line made me take the derivative, so I knew the slope of the tangent line. So this right here is the slope of the tangent line. I want it to be parallel to this line. So I'm going to find the slope of that line. And so the slope of that line is negative 1/2. And so I want it to be parallel, means same slope. So I need the slope of my tangent line. This is the slope of the tangent line, and at some x value, it's going to be equal to the slope of this line. And they're both negative. So I'm going to multiply by a negative, and I get this. Then I'm going to cross multiply. And I get x minus 1 squared equals 4. And you actually don't have to FOIL all that out. If it's quantity squared, you can just square root. And don't forget your plus or minus because of the absolute value. So you have x minus 1 equals 2, or x minus 1 equals negative 2. This will give you x is 3, and this will give you x is negative 1. So all of this must happen in 2 places. Let's talk about what this graph looks like. The powers are the same, so the horizontal asymptote is 1. Vertical asymptote is also x equals 1. And your graph, let's see if you fill in 0. So your graph looks something like this, if you find a few points. The equation of this line right here looks like this. Had a y-intercept of 3. And then if you go down 1 and over 2, so you're looking for the equation of the tangent possibly lines, and you can see that there's probably two of these that are parallel. There's one back here at -1, and there's one over here again at 3. All right, so how do I find the equations of the tangent line? What do I need to do with -1? Hopefully you know that to find the rest of the point, you fill it back into the original. But if you fill in -1, you get 0. And I also need to fill in 3. And when I fill in 3, I get 4/2. So now I can write the equation of the tangent lines because there's two of them that are parallel. So I'm going to say y minus y equals m. Our slope had to be -1/2 times x minus x. So that's one of them. The other one is y minus y equals m times x minus x. It's also pretty cool to type them in your calculator and see them. I don't think my graph's drawn very well, so you might want to look at it. All right, next we're going to do, let's see what number. All right, so the next problem we're going to do is this one. 1, 2, 3. Okay, this one. All right, so be very literal here. You have a polynomial, and it's the graph of f of x has a tangent line with a slope of 10. Let's just do that piece. A tangent line with a slope. So I need f prime of x, which is 2ax plus b. Now as I read on, I know the tangent line needs a slope of 10. So I can say the slope of the tangent line has to be 10. And let's read on. At the point 27. That means all of this happens when x is 2. And if you had a y, you could fill that in also. So it hits 10 at the point 27. It's like gold if you have a point. Use it. It's like a big plus for you. Now that I'm at that, you need to always react this way. If you're given a point, you can always also fill it into the original. Okay? So if f of x or y equals ax squared plus bx plus c, I filled in 2, and my y value is 7. So now I have 7 equals 4a plus 2b plus c. So now I have two equations. And then I have also this point I can fill into the original. So if I fill 0 into the original, I'm filling in 1 for x. I get a plus b plus c, and the y value is 0. So now I have 3 equations, so I can find a, b, and c. Big lesson to you. These are big. If you have points, you can fill them into the original, and it told me the slope happened at 2. So now I'm going to use elimination. Elimination is usually easier than substitution. I'm going to combine these two. I want to get rid of the c's. So the way I do it is I'm going to multiply by -1 and add. So this gives me 7 equals 3a plus b. Now I have these two with a and b. And so I can say 10 equals 4a plus b. I'm going to multiply this by -1. And I'm going to add. That gives me 3 equals a. These cancel out. So now I know a is 3. I can fill it in one of these two to find b. So I'm going to say 7 equals 3a plus b. So b is -2. And then I can fill it in one of these. So I have 0 equals a, which is 3. B is -2. And c gives us this. So you have 0 equals 1 plus c. So c is -1. So my polynomial must be y equals a x squared plus bx plus c. You can check a couple of things. Check your answer with given information. First of all, see if you fill in 2, if you do get 7, in case you made a careless mistake somewhere in here. that gives you 12 minus 4, yep. Then check that you get 1, 0, and if you fill in 1, you do get 0. Then you can take the derivative for your check, 6x minus 2, and the slope of the tangent line when x is 2 is going to be 12 minus 2, which is 10, so everything checks out. So this is my answer to that one.